Hello students, welcome back to the next module of our chapter called electrostatics. Now students, in the previous module we have discussed about tubes of force and tubes of induction. Now students, in this particular module we'll be learning relation between tubes of force and electric field intensity. At the same time we'll be learning relation between tubes of induction and electric induction. Right? Now let us move further. Now before starting with the relation, let us first understand the convention which gives us the number of tubes of force or number of tubes of induction from the given value of charge. So first of all I'll consider the charge, then I'll consider tubes of force, then I'll consider the number of tubes of induction. So if the value of charge is 1 coulomb, then the tubes of force which are coming out of it is 1 upon k epsilon naught, and tubes of induction which are coming out is equal to 1. Right? Now students, do you remember we have already learned that tubes of force depends upon the permittivity of medium, or rather it depends upon the dielectric constant of the medium, whereas tubes of induction does not depend upon the nature of the medium. Right? That's why it is equal to 1, and that's why in case of tubes of force it is 1 upon k epsilon naught. Right? Now let's say the value of charge is 2 coulomb, then the tubes of force which are coming out is 2 upon k epsilon naught, and tubes of induction which are coming out, it is equal to 2. If the value of charge is 3 coulomb, then tubes of force becomes 3 upon k epsilon naught, and the tubes of induction will become 3. And similarly, if the value of charge it is capital Q, then the tubes of force which are coming out is q upon k epsilon naught, and the tubes of induction which are coming out is q. Right? So this convention is very important. Please make a note of it. Right? Now let us move further. Let us understand the concept of electric field intensity, which is given by symbol capital E, and electric induction, which is given by symbol capital D. Right? So students, in the previous slide we have learned about the convention. If the value of charge is capital Q, then the tubes of force is q upon k epsilon naught, and the tubes of induction it is equal to capital Q. Now let us find tubes of force per unit area for charge capital Q. Right? So for charge Q, tubes of force per unit area we'll be finding. Now if the value of charge is Q, then the tubes of force which will be coming out of it, it is q upon k epsilon naught. Right? And let's say if this charge is given to a sphere, then the surface area of sphere will be what? It will be 4 pi r square. Right? So if I rearrange this particular term, so what will I get? I'll get it as 1 by 4 pi k epsilon naught into capital Q upon small r square. And this is nothing but our electric field intensity, which is represented by symbol capital E. Right? So students, thus I can say tubes of force per unit area, it is equal to capital E, which is electric field intensity, and it is nothing but equal to 1 by 4 pi k epsilon naught into capital Q upon small r square. Right? So this is the basic relation between tubes of force and electric field intensity. So what is electric field intensity? It is tubes of force per unit area. Right? Now let us move further and let us calculate tubes of induction per unit area for charge capital Q. Right? Now we'll be calculating tubes of induction per unit area. Right? So for charge Q, what is the number of tubes of induction coming out? It is equal to capital Q. Right? And what is the surface area? Again, surface area is 4 pi r square. Right? So I'll multiply and divide this particular term by k epsilon naught. Right? And if I rearrange it, I can write it as 1 by 4 pi k epsilon naught into capital Q upon small r square into k epsilon naught. Now look at this particular term, this term. That is 1 by 4 pi k epsilon naught into capital Q upon small r square. It is nothing but capital E, which is nothing but electric field intensity. So this particular term can be written as k epsilon naught into capital E. And this particular term k epsilon naught capital E, it is equal to D, which is nothing but electric induction. So what is electric induction? Electric induction is k epsilon naught into capital E. Right? Or rather I can say it is epsilon times capital E, because k epsilon naught, this particular term k epsilon naught, it is equal to epsilon. Right? So I can write tubes of induction per unit area, it is equal to capital D, which is electric induction, and it is also equal to 1 by 4 pi k epsilon naught into capital Q upon small r square into k epsilon naught, and it is also equal to k epsilon naught into capital E. Right? So students, in this particular module we have discussed about the convention, which gives us the total number of tubes of force and the total number of tubes of induction which are coming out from the charge Q. At the same time, we have also learned that tubes of force per unit area is electric field intensity, and tubes of induction per unit area is electric induction given by symbol capital D, and it is also equal to K epsilon naught times capital E, or it is also equal to epsilon times capital E. Right? So students, that's it for this particular module. I'll see you in the next module. Till then, keep learning.